All of you have done this much? Let's talk about physical properties. There are 6 valence electrons that you should know. Physical properties. Atomic size. Atomic size increases down the group. Atomic size decreases down the group. Sorry, increases down the group. Electronegativity. Electronegativity decreases down the group. Electronegativity decreases down the group. We know these things. Electron gain enthalpy. What about electron gain enthalpy? What about electron gain enthalpy? What about electron gain enthalpy? Am I audible to all? Becomes less negative. Becomes less negative as we go down the group. Becomes, we have to remember this statement. Not only decrease, its negative value decreases down the group. Becomes less negative as we go down the group. Oxygen shows exceptional behavior because of its small size. The incoming electron feels an inter-electronic repulsion hence process becomes less favorable. Less favorable. So the order is this. So this we have to remember. Oxygen is at the last. We have to remember this thing. Copy it fast. Oxygen is at the last. You have to remember this. Understood. All of you. Okay. Let's talk about catenation. Catenation किस पे डिपेंड करता है? Catenation depends upon catenation depends upon size. Catenation depends upon bond strength. It depends upon bond strength, which depends upon size. Which depends upon size. Catenation property decreases down the road. Catenation property decreases down the road. So which will have maximum catenation property? Which will have maximum catenation property? Which will have maximum catenation property? See, all things are exactly similar to 15 group. Hence it is easy. शांतनु आपने 15 group ही नहीं पढ़ा लग रहा है यार. What did I say for 15 group? Oxygen shows exceptional behavior because of small size. There is a repulsion between the electron pair because of high electron density on oxygen, repulsion of electron cloud takes place. Repulsion of electron cloud takes place. Bond length increases. Bond strength decreases. Bond strength decreases. Sulfur shows maximum catenation property. Understood? Understood? This is exactly similar as that of 15th group. Sulfur exists as S8. Oxygen exists as O2. Crown structure. Sulfur exists as S8. Oxygen exists as O2. Reason is catenation tendency. Understood. Understood, all of you. Okay. Valency and covalency. What is the valency of 16th group? The 16th group. Covalent 16th group. Covalency of 16th group. What do we mean by covalency? What do we mean by covalency? What do we mean by covalency? Maximum number of bonds that can be formed by an element. Oxygen has covalency of 4. Other elements have covalency of 6. Oxygen has covalency of 4. Other elements have covalency of 6. Why? Why oxygen can maximum form 4 bonds?
Absence of d orbital.
Very good. Oxygen covalency is 4 as not have vacant d orbital. Absence of vacant d orbital. It can form bond and 2 coordinate bond. In those coordinate bond, it will be a donor atom. Understood. If we talk about sulfur, it has vacant d orbitals. So electrons can be excited can form 6 covalent bonds. Understood. Understood. ठीक है. Oxidation state. What oxidation state they can form? They can show. It is N2NP4. Can donate maximum of 6 electrons and can accept maximum of 2 electrons. Oxidation state is from -2 to +6. Oxidation state is from -2 to +6. Understood? Tellurium, polonium generally shows lower oxidation states. Lower oxidation states. Any doubt? Aryan, your message separately. P orbitals. Aryan, you can message in this chat only. Otherwise, I have to go there and check. Why other p orbital conform coordinate bond as they have within the orbital so they can act as acceptor. Aryan, you message in the main chat only. See, sulfur has already formed 6 bonds, and we have seen in coordination compound that when valency is 6, it is the maximum stable compound. If you increase the valency by 6 from 7, 8, 9, it will form highly unstable compound. That is why it does not exceed the valency of 6. Okay, Aryan. Yeah. They generally show lower oxidation state. Why they show? Please mute your mic. Abigail, mute your mic. Why do they show lower oxidation state? Due to inert pair effect. Due to inert pair effect. Lower elements show, but the elements which are present in the down position at the group, they show inert pair effect. Hence, their s orbitals do not get excited. Their s orbitals do not get excited. Understood? Did I give you the definition of inert pair effect in 12th class? That is in the last chapter. Because in school, if you are giving answer like inert pair effect, you have to write down the definition as well. Did I give you the definition of inert pair effect? in the last class, not in 11th class. Last class में दी थी. The reluctance of s orbital to participate in bonding due to poor screening and shielding by d and f subshell. So wherever you are giving answer as inert pair effect, you have to give that definition as well. Wherever you are answering like inert pair effect, better you write the definition as well. Filling of your answer. Understood? Multiple bonding. Oxygen forms p pi multiple bond with itself and with other second period elements. Oxygen forms p pi multiple bond in O2, CO, NO, etc. What do we mean by p pi multiple bond? What do we mean by p pi multiple bond? What do we mean by p pi multiple bond? What do we mean by p pi multiple bond? Must have told you in the 50. क्या होता है p pi multiple bond? Pi bond. Chandru, pi bond formed by p orbitals of both elements. ऑफ बोथ एलिमेंट जो पाई बॉन्ड दोनों के पी से मिलके बनता है उसको पी पाई मल्टीपल बॉन्ड बोलते हैं. इफ इन द फॉर्मेशन ऑफ पाई बॉन्ड one is using its p, other is using its d, it will be called p pi d pi multiple bond. I'll give you an example. It is a very important thing. P pi d pi. For example, O2. O2 we know structure is like this. We know second bond between the same atoms is always a pi bond. Second bond, that is after first bond, whatever bond you are forming within the same atoms, that will be the pi bond. ये sigma bond होगा, ये pi bond होगा. What is oxygen? 2s2 2p4. Is oxygen. Another oxygen. 2s2 2p4. These are lone pair. These are lone pair. Lone pair. These are lone pair. Now, first bond between same atom is sigma bond. Other bond between same atom is pi bond. This pi bond is formed by 2p ऑर्बिटल एंड 2p ऑर्बिटल, तो ये हो जाएगा 2p pi 2p pi. Any doubt in this? Any doubt in this? Any doubt in understanding p pi multiple bond? Why I have written p pi? Why I have written 2p pi 2p pi? Where we can see the lone pair. Everything is there in this figure. Understood this? Understood all of you this? So whenever you have to say that oxygen shows p pi multiple bond, you can draw all this. The more you show the chemical bonding in p block chapter, your answer will become more valuable. p block के अंदर जब भी आप रीजनिंग दे रहे हो, try to use chemical bonding, then it will be very good. ये सब chemical bonding का part है. All of you have copied this. All of you have copied this. और कौन सा मल्टीपल बॉन्ड हो सकता है? p pi d pi multiple bond. What do we mean by this? What do we mean by this? Pi bond formed by d and p orbital of two elements. Okay. Sulfur can form p pi, p pi, p pi, d pi. Oxygen cannot form p pi, d pi multiple bond. Yes or no? Oxygen cannot form p pi d pi multiple bond because oxygen do not have d orbital. Oxygen do not have d orbital. Oxygen do not have d orbital. Understood? Let's sulfur can form p pi d pi. Definitely it can form p pi d pi. I'm showing you that only. Do we know structure of SO3 is like this? Do we know structure of SO3 is like this? sulfur forming 6 bonds. Any doubt in structure? And this sulfur was 3s2, 3p4. 3s, 3p, and 3d. In second excited state, this is ground state. In second excited state, it will be like this. Okay, Abida. 3s, 3p, 3d. First sulfur forms sigma bond. Sigma, sigma, and sigma. So this will be a sigma bond with oxygen. Sigma bond with other oxygen. Sigma bond with third oxygen. Then it forms pi bond. That will be 1, 2, and 3. Pi bond with oxygen 1. Pi bond with oxygen 2. Pi bond with oxygen 3. Oxygen always uses its 2p orbital. So we have 3p pi, 2p pi, 3d pi, 2p pi, 3d pi, 2p pi. Any doubt in this? Okay, d pi, d pi. Sulfur can form d pi as well. Abhida, depending upon the molecule. If it is forming d orbital. If it is forming pi bond using its d orbital, definitely it will form a d pi multiple bond. Thiosulfate के अंदर आएगा. Done. All of it done. All of you understood this bonding? I thought you were asking d pi p pi. Definitely it can form d pi multiple bond as well. And in 11th class, I have showed you the bonding also. How does bonding take place in different axes? You can check your notes. X axis में क्या बनेगा, Y axis में क्या बनेगा, Z axis में क्या बनेगा, that also I have given. All of you understood till here? Multiple bonds. So let's go to compound. I know hydrides of 16 group. Sir, how is 3d pi and 2p pi for last. Pooja, this is d orbital. Oxygen always uses its p orbital. So it is 3d forming pi bond. It is 2p forming pi bond. So it becomes 3d pi, 2p pi. Whatever orbitals are used for the formation of pi bond, that only we are writing. Very good. Okay, let's go to hydrides. H2O, H2S, H2SC, H2T, H2PO. Can we talk about their bond angles? Can we talk about their bond angles? Just wait. Please suggest their bond angles. Bond angle will increase or decrease down the group. This also we have done in the 15th group. Bond angle decreases down the group. And why it decreases? Why it decreases? Why it decreases? Electron density. Why it decreases? Drago's rule. Why it decreases? If M is more electronegative. Reason behind that, Avida. If M is more electronegative, if M is more electronegative, it will attract the electron towards itself and repulsion will be more. So decreases down the group due to decrease in electronegativity of central atom. Due to decrease in electronegativity of central atom. Yes, Malaika. Due to decrease in electronegativity of central atom. And if I say all of them have bond angle near to 90 degree, then what will be the reason? Then it will be Drago's rule. It will be Drago's rule. All of them have bond angle near to 90 degree due to Drago's rule. Drago's rule मतलब unhybrid p orbitals. Unhybrid p orbitals. And this is 104 degree. Understood? Any doubt in bond angle 21? Any doubt in bond angle 21? If we take ammonia and water, which will have more bond angle? Ammonia and water, which will have more bond angle? Ammonia. Ammonia. Why is it so? In water, there is lone pair repulsion, which decreases the bond angle. Which decreases the bond angle. Okay, very good. Understood? Bond angle. Okay. Acidity. Acidity of hydrides. Acidity of hydrides. Which of the following can easily give its H? Tendency to give its H. H2PO. Why you think so, Sahil? As we go down the group, bond strength decreases, hence acidity increases. Very good, Sneha. Very good, Sahil. Pop it fast. All of you understood this? Boiling point. Boiling point. Boiling point. Boiling point depends upon intermolecular forces. Depends upon intermolecular forces. All these have van der Waals forces. Van der Waals force. And this have hydrogen bonding. This have hydrogen bonding. So maximum is H2 due to hydrogen bonding. What about others? What about others? Maximum is hydrogen bonding due to, water due to hydrogen bonding. What about others? H2PO has maximum van der Waals force. Maximum van der Waals force. Due to maximum size, minimum van der Waals force. Due to minimum size. मतलब H2PO, H2TE, H2SE and H2S. ये ऑर्डर ऑफ बॉइलिंग पॉइंट हो जाएगा. Understood? Stop it first. So maximum volatile and minimum volatile. Maximum volatile and minimum volatile. Maximum volatile H2S. क्योंकि volatility is inversely proportional to boiling point. And minimum volatile will be water. Understood?
Sir, why NH3 didn't have maximum boiling point then?
Again, what?
Sir, why NH3 didn't have maximum boiling point even it has
They are,
hydrogen?
yes, that is an observation, experimental observation. See, hydrogen bonding and van der Waals force both are weak van der Waals forces. अब कौन किसके ऊपर कब dominate करेगा, that we cannot predict, that we can only observe. कोई चीज किस टाइम पे मेल्ट हो रही है या फिर बॉयल हो रही है वो हम केवल ऑब्जर्व कर सकते हैं. ओके, दोनों वीक van der Waals forces है, anyone can dominate other on the other one. वहां पर the hydrogen bonding is dominated. यहाँ पर hydrogen bonding is dominated over van der Waals forces. Their van der Waals forces are dominated over hydrogen bonding. It is just an experimental observation. Okay.
Okay, sir.
Yeah. याद ही रखना पड़ेगा. Observe है. If we say that H2O is a liquid while H2S is a gas, what can be the reason behind it? Yes. H2O has hydrogen bond. See, liquid and gas depends upon intermolecular forces. Physical state of a molecule depends upon the intermolecular forces. Depends upon the intermolecular forces. No, Kinman, here electronegativity will not work. Not at least directly. You can say oxygen is more electronegative, so it will form hydrogen bond, but that will be a long route. You simply have to say that physical state of a molecule depends upon the intermolecular forces. Water has stronger intermolecular forces, that is hydrogen bond, and H2S has weaker intermolecular forces. Topic first. Can we talk about vapor pressure also? Which has more vapor pressure? H2O or H2S? Which has more vapor pressure, H2O or H2S? Which has more vapor pressure, H2O or H2S? Boiling point is inversely proportional to vapor pressure. Boiling point is inversely proportional to vapor pressure. Boiling point is inversely proportional to vapor pressure. Lesser the boiling point, more is the vapor pressure. Lesser the boiling point, more is the vapor pressure. Lesser the boiling point, more is the vapor pressure. And okay, Kinman. Lesser boiling point, more vapor pressure. तो H2S होना चाहिए ना. धो दो, डाल दो. ओके, ये वेपर प्रेशर हो गया. थर्मल स्टेबिलिटी, thermal stability, thermal stability, decreases down the group. Very good, Sneha. Reducing character, reducing character, increases down the group. This all we have done in the 15th group only. Explanation also I gave there only. Okay. Dipole moment. Dipole moment. It is directly proportional to the electronegativity of central atom. Directly proportional to the electronegativity of central atom. So decreases down the group. ये सब उनका लेके जाएगा वो. Done. Any doubt? Madam, oxides of 16th group. oxides of 16th group. So it can show oxidation state in +2 oxidation state, +4 oxidation state, +6 oxidation state. Like sulfur can form SO2, SO3. It can form sulfur monoxide as well. Okay. Selenium does not show +2 oxidation state. It can show SeO3. It can also show SeO2. Tellurium, tellurium and polonium can easily show +2 oxidation states due to inert pair effect and unstable compounds of this. Unstable these compounds. It will not show only this particular compound. Copy it fast. Oxides of non-metal are acidic in nature. Oxides of non-metal are acidic in nature. If we take SO3 and SO2, which will be more acidic? Which will be more acidic? This we have done in 3rd chapter, 11th class. Which will be more acidic? SO3. Greater the positive charge on central atom, more tendency to accept electron and hence more acidity. More acidity. Very good, Abhida. If we take SO2, SeO2, TeO2, POO2, what will be acidity order? It's +6. It's +4. Sorry. What will be the acidity order? Positive charge is same. But positive charge density decreasing. effective nuclear charge, effective nuclear charge decreases down the group. So acidity decreases down the group. Understood? Copy it fast. Just wait. Wait for 2 minutes. Done, all of you? Okay. SO2 is like this. SO3 is like this. It has p pi p pi, p pi d pi, multiple bonds. It has p pi p pi and p pi d pi multiple bonds, which we have already done. H2S can act as reducing agent only. SO3 can act as oxidizing agent only, but SO2 can act as both. Why? SO3 is present in +6 oxidation state. This is present in -2 oxidation state. It can only decrease its oxidation state. It can only increase its oxidation state. So it can act as reducing agent, दूसरों को reduce करके खुद को oxidize करेगा. It can act as oxidizing agent, दूसरों को oxidize करके खुद को reduce करेगा. It can decrease as well increase its oxidation state, hence can act as both. Hence can act as both. Understood? This question we have done in redox chapter also. This question was there in redox chapter as well. Done? Chalo. All of you have completed this? What should be the product of this? इस वाले का बताओ पहले. What should be the hydrolysis of SO3? This is +6 oxidation state. +6 oxidation state. Hydrolysis of SO3 gives H2SO4. Oxidation state remains same. SO2 reacts with 2 water to give H2SO4 plus 2 nascent hydrogen. SO2 plus 2 H2O gives H2SO4 plus 2 nascent hydrogen. This have bleaching action. Bleaching action. What do we mean by bleaching action? Nascent hydrogens have bleaching action, that is they can convert colored matter to colorless. Colored matter to colorless. Okay, copy it fast. colored matter to colorless. It is a temporary bleaching action. Copy it fast. Done. Halides of 16th group. Write down halides of 16th group. Halides of 16th group. Three kind of halides it can form. Copy it fast. Selenium forms unstable dihalides. O OF6 does not exist. SF6 exists. What is the reason behind it? OF6 does not exist. SF6 exists. Oxygen cannot form more than 4 bonds because its covalency is 4. Hiba, do not say that thing because you may get a case of coordinate bonds and it may show +6 oxidation state. Talk about covalency. That will be better. In nitrogen also we said it can show +6 oxidation state but in coordinate bonds. तो अभी कोवेलेंसी के बारे में बात करो. 6 बॉन्ड नहीं बना सकता है एनी हाउ. Sulfur has vacant d orbitals, so can show or can form 6 bonds. You can simply expand this answer. You can show how oxygen does not have d orbital, sulfur has d orbital. You can expand this answer. Why that chemical bonding only? ठीक है. इंपॉर्टेंट क्वेश्चन है ये स्कूल के लिए, तो इसमें केमिकल बॉन्डिंग का यूज करो, ग्राउंड स्टेट दिखाओ, एक्साइटेड स्टेट दिखाओ. ट्राई टू एक्सप्लेन दिस आंसर मोर. SF6 exists. SCl6 does not exist. Why? Sulfur cannot accommodate 6 bigger Cl atom around it. Highly unstable structure. Highly unstable structure. Okay. Both things we can use. Due to the large size of Cl atom, there will be steric hindrance. But steric hindrance जो है वो reaction के लिए use करते हैं हम. Do not use this word. We'll use this word in organic chemistry. Steric, no one can understand this. Or we'll say that the bigger size of Cl atom will collide with other Cl and the structure will, you can say, will get decomposed. Not accommodate 6 bigger Cl atom around it. Highly unstable structure. ठीक है, steric hindrance नहीं बोल के बोलेंगे due to the large size of Cl atom. If you remember, we have done such questions in 14th group 11th class as well. CF6 does not exist. SiF6 exists. SiF6 exists. SiCl6 does not exist. So we have done those questions in the P block 11th class as well. It's quite similar. Copy it fast. SF6 is highly stable molecule. Do not undergo in any chemical reaction. This can be the statement. SF6 is kinetically inert. This can be the statement. SF6 does not undergo hydrolysis. This can be the statement. ये तीन तरह से क्वेश्चन आ सकता है. It is highly stable, does not undergo any chemical reaction. It is kinetically inert. It does not undergo hydrolysis. Question can come in these three forms. हमें क्या लिखना है आंसर? In SF6, sulfur is sterically protected by 6 fluorine atoms. Hence, it is highly stable. उस पर इसका स्ट्रक्चर बना देना है. That's it. It is very important question and this word is important. ये word आपको use करना ही है, अपने हिसाब से English नहीं लिखनी है. You have to use the word sterically protected. Sulfur is sterically protected by 6 fluorine atoms, hence it is highly stable. Then you can make the structure, and that will be the answer for any of the 3 questions. Understood? That's it for today. Rest we'll do tomorrow if I keep some class. Otherwise, in the main class. Okay. Thank you.